Hi everyone, my name is Vellanki Venkata and my register number is 18BEC0112 and my slot is C1. Now I am presenting my digital assignment 2 topic of computer organization and architecture, and my topic is a floating based type data type for resilient deep learning interference, and I am doing this course on a Professor Danbar. My professor has given me some set of questions. Now I am going to explain those questions and explain how the selected paper related to a COA syllabus and curriculum. In this paper basically deals with the arithmetic and logic operations on floating point members and the arithmetics to perform the same, and the floating point unit mentioned in our syllabus is in basic model, and I have chosen a general that consists of a modifications to a traditional system to enhance the performance, and the floating point arithmetic block may be figured in to implement a variety of floating point arithmetic operations, including the inverse square root operations, inverse operations, division, multiplication, addition, and subtraction operations. And now one now since one of the primary task of arithmetic logic unit involves performing operations on floating point members and generating described results, and this paper can be perfectly related to our computer organization and architecture syllabus. And the second question is, draw the existing architectures discussed in the paper using appropriate raster graphics editor software in encapsulated PostScript file format. And this is the block diagrams that are discussed in my paper, and these are the two diagrams that are discussed, and have drawn this in an encapsulated PostScript file format. And the third question is, draw the tabulated results graphs using an office suite in encapsulated PostScript file format. And these are the tabulated things that are presented in my paper, and these are some of the graphs relating to these tables. And the fourth question is, draw the proposed architectures discussed in the paper using diagram and vector graphic applications software in encapsulated PostScript file format. And this is the block diagram of those things, and this consists of a POE and PE1 and PE2, PE3, and GB. And the fifth question is, draw the transistor level internal diagrams using an electronic scheme capture and stimulation tools in encapsulated PostScript file format. And this is the internal diagrams using an electronic systematic captures, and this is the stimulation of this diagram. And the sixth question is, compare the proposed architectures with the existing architectures in your reference books. And the existing architecture calculates using the conventional methods of manipulation by shifting, subtraction, etc., and process is relatively time consuming, and answer obtained is accurate, and the conventional method consumes the level processing that proposed in an intensive approach, and method is not very expensive, and bias may be produced in while rounding off. And for and and this is the example for those existing architecture. And the next one is proposed architecture. And the proposed architecture defines a new approach by consuming an initial solution and arriving at a final result using a numerical techniques with the Newton-Raphson method in this case, and based on initial assumptions, proximity to an actual solution, the process of leading to an con- convergence to obtain a final solution may be fast, and this is the example of those proposed architectures. And the next question is, list the advantages of a proposed design over an existing design. And these are the advantages I have written. These are the advantages of proposed design over an existing design. And the advantages are increased power efficiency, low power consumption, reduce the delay, and boost in the performances. And these are the list the merits and demerits proposed in the architecture techniques hardware. And these are the merits are the cost renewability, high performance, and this is the demerits. And the demerits are the field image of image processing, and especially the stream based by the computation of inputs pixels of an image to exploit the low level consumption capability of hardware to open a gate gateway to more complex images and proposing tasks which take computationally long time to work in a general purposes and this is the example for that and the ninth question is list the applications of an proposed design this is the applications I have written. And the closeness of floating point represents to an actual value is called an accuracy, and all these special numbers as well as the special members are the subnormal members represented to use special bit term in the explanator, and in the function analyzes results and the synthetic results are measured in the precise and accurate manner. And floating point consumption is used in systems which included very small and very large real members which requires fast processing times. A floating point time can be used to represent with fixed numbers of digits and numbers of different orders of magnitude, and the distance between galaxies and the diameter of an atomic nucleus can be expressed with the same unit of length, and the result of the dynamic range is the number that can be represented or not uniformly spaced, and the difference between two consecutive representable numbers varies with the chosen scale. And floating point members with the find the application in several practical aspects such as tensor processing units and high dynamic range images and gamma encoding. And the proposed approaches tends to a simply floating point and arithmetic to a great extent, and therefore the Newton Raphel algorithm is based on the design surface services a variety of practical applications as mentioned above. And the last question is draw the flow chart or the diagram of the transistor level circuit proposed in a design and encapsulated proposed postscript in file format. And this is the uh, algorithm of that and of my paper. And thank you for giving this opportunity.